All right, great.
Okay,
All right,
take it away.
cool. Well, thanks everyone for joining. I'll be covering pros processing or just all processing in Siril, really. We want to, I know there have been some tutorials and some classes here that have been done on PixInsight, but we want to try to do some showing some of the free software, especially if you're just starting or you're just looking for something different than the typical PixInsight, without having to shell $500 on just software. So goals for tonight is, go over a difference in broadband. So what's typically done as LRGB and narrowband, which is the sulfur, oxygen, hydrogen images and the colors. This is kind of universal, not just for Cyril, but I think it's important to understand, especially if you're just starting with processing, regardless of software, to give you a better idea of what I'm doing, some of the things that I'll be doing. And then really the bulk of it will be demonstrating how to use Zero. And for the example used tonight, it'll be multi-node processing of a narrowband imaging. So I'll go briefly over how to install Zero, just general navigation on using the software, installing and using some of the scripts we'll be using, stacking our images, and then manipulating it and making it look pretty. I won't really go over details of image acquisition, but we did schedule a class for, coincidentally a month from now. Funny how those new moons happen all the same cycle. And we'll go over the details of image acquisition there. So for now, we'll just talk a little bit about filters and lights. Also, if you have a question, feel free to drop it on the chat or raise your hand, and Wes will grab my attention to go over your question. All right. With that said, any questions so far? All right. All right. Like I said, before we started, I think it's important to understand what it is we're doing with the light and the colors. Um, so really, we're looking at the electromagnetic spectrum, right? So that's a fancy word of saying, right, light is made of photons and they move in a wave pattern, right? Meaning they're going up and down while simultaneously moving forward, right? So it makes a little wave, and they carry energy. So really, that energy is what we see as light. And the type of energy they carried, it's classified, it's named by the frequency, right, or the wavelength at which they move, right? So that we, words that you hear, radio waves, microwaves, which we use almost daily, right? There's the visible light, which is a spectrum of light we can see, UV radiation, X-rays, gamma rays, etc. Right? Those are all part of the electromagnetic spectrum. They're just moving at different wavelengths. And so for astrophotography, what we care about is this portion here, the visible light, right? And so, or the nebulae that we're typically shooting when we're doing deep sky objects are consisting mostly of hydrogen with some oxygen and sulfur, and they emit light at very specific wavelengths. And so when we capture those specific wavelengths, that's what we call as narrowband imaging, right? We use filters to isolate those specific wavelengths. And, picture's worth 1,000 words. So here's a little example of the electromagnetic spectrum, right? Go all the way from radio waves all the way to gamma waves, right? So like I said, the wavelength, right? It's the distance between peak to peak. So from here to here, right? That will be our wavelength. And then the frequency is how long it takes to go from here to here, right? So you can see here an example of what the different wavelengths we use for different devices, right? So we use these all for different aspects in our daily life, but we can only see this small portion right here of it, right? It'd be kind of crazy if we could see the whole thing. I think we'd go nuts seeing all the different waves going around us. Um, but for astrophotography, it's just a little bit here that we care about, right? Um, and so that's where, when you hear things like LRGB or broadband, as it's called, or narrowband, that's what it's talking about, right? So if we take this little spectrum here, right, and isolate that, right, and plot it here, right? So here's the wavelength that we care about. And so when we're talking LRGB, we're covering the entire visible spectrum, right? Which is from around here, the high 300s to about the low 700s in wavelength, in nanometers, right? So almost 400 nanometers to slightly beyond around 700 nanometers. That's our visible wavelength. So we can do the images in two ways, right? We can do broadband, which is we try to capture the entire spectrum with the RGB, red, green, blue filters, right? So in this case, we have one filter that's the blue filter that covers a spectrum from around 400 to around 500, right? Then there's the green from around 5 to 6, and then red from about 6 to 7, right? And different manufacturers of filter, they'll expand those ranges based, right? So for example, on this one, something that I've seen a lot, you'll notice there's a gap here between the green and the red, and there's this line here highlighting mercury and sodium, right? So that's because streetlights, at least used to be, mostly mercury and sodium. So by leaving this gap here, you aren't missing much of any light emitted by any of these type objects, but then we could do some sort of light pollution filter by avoiding capturing the light from streetlights. Unfortunately, nowadays, a lot of the streetlights are LED, and LED, again, it's the entire visible spectrum. So you're not really gaining much by not imaging that. But what you can, right, and another thing, so for broadband, we have the RGB, and then you can add another filter, right, your luminance filter, which will cover this entire range simultaneously. So you use your RGB and you get a color image, and then you add a lot of detail with this luminance filter, which is really, you're covering the entire spectrum all at once. Right, so that's if you're using a mono camera and you're separating your different filters. If you're using a one-shot camera, you basically are taking pictures of RGB, all three simultaneously, right? Really, you're taking RGGB, so you're taking a little bit extra green. Or you're also covering this whole thing simultaneously without having to change filters or whatever that. But if you want to be a little bit more focused, right, you can do narrowband, right, and really isolate the sulfur, hydrogen, and oxygen, right? They emit energy at very specific wavelengths, right? So you see them here. Here's the hydrogen. Here's the sulfur. Here's the oxygen, right? It's a very, very specific wavelength. So if we can isolate just this little bit of light, we can avoid a lot of the light pollution as well, right? Because now we don't get any light, right, between this green and red here, between the edge of the blue and this oxygen here, right? So it's a very little light that we're getting. So it's great to capture some deep sky objects, but then at the same time, your imaging time, integration time has to be much, much larger because again, you're only capturing a very little sliver of light from across the entire visible spectrum. So we're talking about RGB, right? But we see more colors than just red, green, and blue. But why do we focus on those three? So it just really, there are different color models, right? So there's the RGB, there is the cyan, magenta, yellow, and some other ones. But RGB is just a really efficient color model, and it uses what's called additive primary colors, so red, green, and blue, to create any other color, right? So if I mix red and green, I get yellow. If I mix green and blue, I get cyan. If I mix red and blue, I get magenta, right? And if I start mixing that light at different intensities, right, I can get different colors between red and green that is not just as yellow, right? And if I mix all three at the same level, I will get white, all right? And so your computer screen also in any TV screens, they all use the RGB, right? You can actually do a rough white balance of your screen if you have a good white reference, right? The an iPad or an iPhone, those are considered to have really good white balance to the screen. So if you get a white screen on one of those devices, you take your computer monitor, you make it all white, and you compare the two, you can then open your computer monitor, right, and start playing with the red, green, and blue light that it's emitting to try to match that iPhone or that iPad. And that's how you can, right? Maybe you notice that when you put the two next to each other, that your computer screen will have a slightly red hue compared to your iPad. So you can turn down the red on your computer monitor, right, and achieve that perfect white balance. So that's kind of a rough way to do it. But that's what we worry about RGB, right? It's just an efficient color model um, to create any colors we want, right? So like I said, there are others like the cyan, magenta, yellow, which is what printers use. If you notice, when you buy ink for your printer at home, you're buying cyan, magenta, yellow, and black, right? That's called a subtractive color model because what it's doing, it's subtracting color from the white paper. So basically, think of this wheel here kind of inverted, and that's what it is. So RGB is an additive color model, right? We're adding color to a black reference, and this CMY is subtractive, so it's taking away light or color from white. Right, and our eyes are receptive, most receptive to wavelengths near red, green, and blue, not exactly red, green, and blue. So that makes it also an efficient color model for us to use here. All right, so why am I talking about colors and wavelengths and all this stuff when this is about Siril? Well, so knowing which frequency here we're going to map, especially for narrowband imaging, allows us to create very specific color palettes in our images. And if we understand a little bit of color theory, then we can modify these RGB, right? Because that's really what we're doing. We're going to take those filters, the sulfur, hydrogen, and oxygen, and map them to one of those RGB, whether it's directly 1-to-1 or we're combining it with some sort of ratio. What we're doing is we're still doing an RGB image at the end of the day. And so if we understand the color theory, it will allow us to then obtain specific shades or hues that we want, right? And then, like I said earlier, this translates to any software we use. So if we know kind of what we're trying to do, all we need to do is figure out what knob we need to turn in Siril to obtain that desired effect, right? And then you can take the same theory and then try to do the same whether in PixInsight, Photoshop, GAMP, or whatever you want to do at the end of the day. And when we talk about narrowband, you'll hear a lot of things like the Hubble palette, right? That's what made kind of this SHO famous because they map hydrogen and sulfur to red, hydrogen to green, oxygen to blue, and you get these really pretty images that are technically not the real color of the nebulae. If we could somehow travel there and see it directly, but what it allows you to do is look at an image and then determine what the molecular composition of that cloud of gas that you image, right? So when you see red, oh, that's sulfur. And then if you're seeing yellow, right, that is some combination of sulfur and hydrogen because you map those to red and green respectively. And then depending on the shade of yellow, how red or how green that yellow is, so you can kind of determine how strong those gases are, right? So that's you can kind of now see why that's useful. All right. So now let's talk about Siril, right? So Siril is a free, that's the important bit here, astronomical processing tool developed by Richard Siril. Here's the link. You can go download it. It's a really easy install. Just download it, click on the executable, and just click next until it's installed. The current version, latest version is this 1.4.0 beta 4, which is the version we'll be using tonight. It's fairly stable. Sometimes if you try to do way too much too fast, it'll crash. So if that happens tonight, apologies in advance, but it is a beta. They do have a more stable release, 1.2.6. It's quite old by now, and there are a lot of features in this 1.4.0 beta 4 that are really useful. So that's why I'm focusing on using this one. And then there's a couple additional free scripts that are developed by other entities that enhance the image processing, right? If you've heard of PixInsight, the RC Astra tool for denoising and sharpening and star removal, that's kind of what these are doing. They're just free, which is great, right? So we can do star removal with StarNet++. And then we got some AI tools for sharpening and denoising as Graxpert. And by the way, I believe StarNet. No, you can't. I thought you could use it in Photoshop directly, but you can't. But if you ever play around with PixInsight or you move to it, you can actually use StarNet and Graxpert PixInsight as well. So I have the links here. So you'll just download the files from the links here. Graxpert, you would actually just install it directly, and then I'll show the little bit of installation you have to do in Siril directly for both of these. And for StarNet, you would just unzip the zip file you get from here. All right. So the example I'll go over tonight, it's the California Nebula and sulfur, hydrogen, oxygen that I shot over 3 nights. It was just me trying around the new camera. So I have here how much data I'm playing with. It's not much, and you'll see that it's still quite noisy. Like I said, with narrowband, you really want to get a lot of integration time to really get a smooth image. I just kind of got a target ADD and jumped around, and I just need to come back to it. But it kind of demonstrate kind of how much you can push a little bit of data and the importance of just really focusing and getting on one target and getting a lot of data on it. But yeah, about 8 hours in total, a little shy of 8 hours. So for each one of these nights, so each night I shot all 3 filters. So for each night has its own set of flats for each filter. So 9 sets of flat total. Same master dark for all the lights. In Siril, I actually use a numerical bias instead of taking bias frames, and I'll go over that here in a second. And I shot this here from my backyard, which is around Bortle 5, maybe high 4s on a good night, closer to 6 on a bad night, on a Redcat 51 and a Player 1 Poseidon on a camera. All right, so with that there any questions so far? If not, I'll open Siril now, and we'll start doing the actual tutorial bit. All right, so let me just resize here my screen with Siril, and I'll start sharing. All right, can you guys see the screen fairly well? All right, so this is Siril. When you open it, this is the screen you get. So a couple different things to go over here on navigation. So all your image processing, stretching, color calibration, filters, all that, it's here on the image processing. Under tools, we'll find things like your plate solving, looking at different image statistics there, and then image analysis. You got some other ones. It's all grayed out because I don't have any image loaded here. Under scripts, you got a couple different Siril scripts developed for your processing directly, and I'll go over that here, or some Python scripts that you can download it or install directly from Siril, or you can write your own if you kind of know what you're doing, either a Siril script or a Python script. All right, and then the last one over here, if you ever see a tutorial or read about a tutorial, here's the preferences menu that they call the hamburger menu. There's 3 lines, sort of resemble a hamburger. So here are a couple of different preferences for it, right? Whether how you want your default type to be. Actually, I'm gonna change this to 16 here for a minute. If you want any compression, this is a bit important. So Siril, it creates a lot of files when it's doing the stacking, and it can easily eat your hard drive. You can see here your desk space, and I've gone from like 700 gigabytes to running out of space by trying to stack like 5 nights together. So because it defaults to 32 bits, which with my camera, each file is about 50 megabytes. But in it's 16-bit, but then when it converts to 32-bit, it doubles the size, and then that very quickly eats your hard drive. So I would recommend keeping it at 16 until you do the very final stacking. Another thing you can do is do some compression if you're kind of running out of space. You'll notice here the 16-bit says on-site integer, the 32-bit says floating point, right? Integer meaning one is 1, right? And a floating point would be like 1.0 or 1.001, right? I've heard, I haven't really played around to verify it, but if you use the integer here, when you do a compression, it's a lossless compression. So that might be worth doing if you start running out of this space here. And one thing I want to go over here under miscellaneous, here's when you install your StarNet in your Grasper, right? So for StarNet, here you would point directly when you download StarNet, right? You unzip that file, you get this, and then you select this executable here for it. Then for Grasper, you gotta navigate to where you actually have to install it like you install any normal piece of software, and it's its own standalone software as well. You can just open Grasper directly. You don't have to use it within Siril. But if you want to use it within Siril, you got to point it to the executable that you installed. You just follow all the default places for the installation. It's kind of on a very random place. So what I do is I just do start and type Grasper on Windows. I can do open file location. Right, you'll notice this long path. This is the executable we want to point to it in Siril, right? So I would just copy this here, and that's the one I point to, right? So you want to set those 2 up to be able to do the some of the processing we'll do later on. So let's start now with actually taking the images and stacking them, right? So the first thing you want to do is decide how you want to stack them. If you want to stack them manually or you want to stack them with the scripts, right? So the script here, you'll hear there's some on a pre-processing, one-shot camera. If you use a narrowband filter, it'll go through your frames and extract just the H alpha, right? Since most narrowband filters for narrowband are hydrogen oxygen together, right? Because it's a one-shot camera, so this will extract just the hydrogen. Kind of cool if you're doing some galaxy and you want to add a little bit of hydrogen to your galaxy. Or if you're using RGB, it'll go through those and kind of extract, kind of like a pseudo narrowband, which is actually in hydrogen and oxygen. Or here there's this one-shot pre-processing, which assumes you have biases, darks, and flats. And you just click this. You gotta, I'll show you here in a second, you gotta go to your working directory and it'll just go ahead and process all your flats right away, or your lights and everything without having to do anything manually. Same thing here. If you want to do some drizzling with your images, so if you did your images and you want to drizzle, which will help a lot with the noise reduction, this is the one you pick. And there are a couple of other options here. So if you're gonna get to more, you do get scripts. It brings you to this menu here, and you can look at the different utilities and scripts they have. Right, if you want to try any of these out, you just click here in the box and click apply. For some of them, you have to download another executable from the internet, and then when you open the script, it will ask you to point you to it. This cosmic clarity. If you guys have heard of SETI Astro, which I know has been getting kind of popular recently, these are his scripts here. So you download them, then when you open the script, it would ask you to point to where in your computer the executable is. So you have to go download from his website. But you can see there are a couple other ones here for stacking. So you can do it if you don't have flats, DBF, so darks, biases, and flats. If you want to process without darks, if you want to do a little bit of background extraction while you're processing, then I'll go over that here in a minute. But these scripts are great and they're really easy to modify if you want. However, they just assume you're doing one single night, or at least that if you're doing multiple nights, you're using the same calibration file, so same flats. Or you can use the darks for all of them. If you have a cooled camera, if you have a DSLR or a mirrorless camera, you wouldn't be using the same dark. So using these scripts is hard with them unless you modify them yourself to go over them the multiple nights. All right, so we're gonna do it manually. And so the first thing you do, you'll notice here there's open, where you can open one file directly, and then there's home button. This home button, you select a working directory. That means that any file that outputs, it will output to that directory. So here's my California nebula, right? So here, the way I have it set up is I have the different nights where I took the images. And in each night, I have my lights. I have a script that I run automatically when I take the pictures that just sorts any bat frames directly here into this bat lights folder. I have my flats. And then these files were created when I was playing around with the images. So I usually make a working, call it a working directory. It'll just output a lot of the serial stuff that I just end up deleting because it takes a lot of space. Here's what I put the calibrated lights, which is what we use at the end to register, and the masters for my flats. So for now, I'm going ahead and pick this working file here as my working directory. Open. That's it here. All right. So the first thing I want to do is let's start with the flat frames. So with the flat frames, you want to calibrate them using your bias, right? And before you actually use them to calibrate your light images. So first thing you gotta do is you gotta come here, click that plus, and load all your flats. So I gotta do this one filter at a time. So we'll go here to flats, select what filter. Let's say I want to do the hydrogen, and I took 50 flats here. Select all of them, do that. Right. Now the sequence name, so what it's gonna do, right? It's gonna take all these. I'm gonna give it a name, and let's call it flats hydrogen 1 for the first night, right? And what it's going to do is going to take each one of these files and rename it as flats _h _1, and then it's going to go _001, 0002, so on. Right. And the symbolic link, what that does is instead of creating a new file, and just easier if I do convert, right? So now if I go to my working folder, you'll see I have now these 50 files, right? With the same naming convention I just went through. And you'll notice that they are all 0 kilobytes, right? Because what the symbolic link, what it's doing, it is linking directly to the original file. So it doesn't really create a copy of it. So that creates also this text file here where you can open up. If you have an issue, right, it might tell you, hey, I had an issue when I was doing this flats 25. So you can come and open that one, look at here, and it'll tell you what that's linked to in your original files, which is useful because sometimes I'll have an extra file in here, like a PNG from a graph I created for all of these, for example, and I'll load it in by accident. Then when I go to stack them, it'll tell me, hey, I had an issue with, 32, and then I come and look at 32 and like, oh yeah, that's that PNG file. Then I'll have to go take it out. All right, so that's what that there, right? And then it creates a sequence. When I come here to sequence, you'll see it automatically loads the latest sequence that you did. The sequence just points to all those 50 files. So everything now I do, if I do it on the sequence, I will be doing it on all those files at once. All right, so now that I load all the flats, I want to calibrate them. So I come to the calibration. And then here I get to pick what bias, dark, or flats I want to use, because you'll be using this to calibrate lights as well. So for flats, I want to do bias. And like I said before, I will do it right. I'm picking a master bias file. I'm going to do a numerical bias. I believe it's just you do 8 times offset. All right, so this is going to take the offset I used in my images and multiply that by 8. And that'll be my bias. And there's a really good article on the Siril website where they tell you how to come up with this number right here, depending on your camera and the bits that you're using. And the reason they recommend using this numerical bias is to avoid adding any additional noise by introducing a bias frame. Since the bias should be constant in your camera, you can do this. I don't know, with today's cameras, really, I don't know that it matters much. You could probably get away without even using it. But when I use Siril, I like just doing this number because it's easy. All right, so when I do that, I want to make sure everything here selected makes sense. I don't want to debayer images. If I had a one-shot camera, I would be debayering the lights at the end. But even for flats for a one shot, I want to be debayer here, and I want to do that. I just do start calibration. There's a trick here too. There you go. So just to go back, it has to be equals, and then you're gonna put a $sign next to offset, so it knows to grab that. It'll grab the offset from the fits header, from the header and the fits files in your images. All right, and so you notice that when I click, I'll do it again, calibration, and it comes back to the console, and it's giving you a status here and telling you, yep, I did it. Did it under a second, right? And well, I had it redone again, right? Because that's the sequence I want. So you'll notice when I come now here to my working file, you'll notice here it had this prefix PP for pre-processing underscore, right? So now I have flats here with this image, and now it creates this PP underscore that image. And notice that now these do have some size, right? So it starts adding up, and because I did it again, as soon as you do something, it loads that sequence automatically. And when I hit start calibration again, it had this PP sequence already in there. So that's why I have this PP underscore PP. So I'm actually going to go ahead and delete that one. And it also adds the sequence file, right, which points to all these files. All right. And so I would do the same thing now for all my flats for every night. So I would have to go do this 8 more times for all my nights, or my flats for every filter, and calibrate all the flats using this numerical bias here. And for every night I would change this, 2, 3, or more if I have more. All right, and you can see it gets pretty tedious if you have a lot of nights. What I've done in the past is write a couple some Siril scripts here. You'll see it pretty simple. If I right click on one, it'll open it here. Right, they're pretty straightforward. You can kind of take one that already works and follow this their format here to do your stacking. And the way the scripts work is once you're in your working directory, you kind of have to be you have to have some format, a specific format, right? So you would want to have for one shot camera, it's actually this format, right? You'd have your lights, and then in this lights folder, you actually would have all your images. For flats, you would have all your images. You would have another folder with darks. You have all your darks, another folder called bias, where you have all your bias. And then if you make this top folder here your working directory, and you run the script, it would automatically go through all those and create your images. If you want to do it mono, you got to do it the opposite way. You see how my structure is lights. Then when I click lights, I have the filters. Well, you do the opposite. You do a filter, and then inside this folder for the filter, then you have folders for lights, flats, darks, and biases, and so on. But once you have that and you just click on the script, it will run. All right, so I'm going to keep working with this hydrogen one just to keep it simple. But again, you would be doing this for all of them, right? All your flats for every night. All right, so now if I want to now move on to the lights for my hydrogen, I'll select all, and then here delete. I'm going to load the lights for hydrogen. Oh, before I do that, okay, so I got this sequence. Now my flats are calibrated, but they're still individual, right? I want to create one master flat. So I want to make sure that my calibrated flat sequence is selected here, and I come to stacking. I would do here average stacking with rejection. For flats, I would click multiplicative. For pixel rejection, this is fine. I don't want any weighting for flats. And this is all okay. I can leave it like this. And then it's telling you where you want to save it, right? By default, it would save it in your working directory under this name. It would take the sequence name, which is pp underscore flat underscore h underscore 1. And it would just add the name, the word stacked at the end. And what I want to do is instead of saving it here, which my working directory is this working one, under all these, they will be hard to find and I could delete it by accident. I'm going to actually go one folder back, which would be here, and then select masters. So that way to do it here is you do ... which tells it to go right in slash, which tells it to go back one folder. So if I'm here, going back one folder is here, then I want this masters folder. So then I go masters slash, and I want to pick a name here. Let's call it master hydrogen 1. All right, for first night, then just start stacking. And very quickly stacks all of them. All right. And one thing you want to keep an eye on is when you do the pixel rejection that it tells you, you want this to be between 0.1% and 0.5. If it's higher or lower, you want to play around with the sigmas here to try to lower the number, right? So if it's higher than 0.5, you would add to the sigma high. If it's lower than 0.1, you would add to the sigma low. And that just helps you with reject more pixel reject. All right, so now I have a master flat. So if I come here to masters, right? Well, I had one called HA. I just made one called H. Right. So this is my master file right here. All right. So now that I have that master flat, I can use that to calibrate my lights. So I'm gonna do that. So the first thing I gotta do now is load my lights for that filter. So go to lights, hydrogen, right? Like I was saying here, like notice I have this PNG, which is a plot showing me what images, some statistics about my images. So I'm gonna make sure I don't select that one. Right, and I'm gonna call these lights H. Convert. Again, I notice here my sequence is already loaded here. So then go to calibration. So I'm not going to use the bias. I'm going to use the darks. And I already have a master dark that I want to use, right? And to make a master dark, you do the same thing. You load them all up here. You don't need to calibrate your master dark, so you go straight to stacking. Maybe you do additive with scaling. You start stacking, and then your resulting file will be your master dark, right? So I've already done that. I will come to here, and I have a folder here called masters for this camera, masters, and I want to use the one for, right, I have a dark. My exposures were each 3 minutes, so minus 10 degrees, so this is the one I want. And the master flat is the master flat we just created, which would be masters here. All right, and all these settings are fine. Actually, what you can do here too is I can do estimate, and if you notice any of these values go red, then you can play around with these sigmas to make them go not red. All right, so I'll do that, and now I calibrate my lights. All right, so now I have lights calibrated. You'll notice here that you can kind of see the outline of a nebula here, right? And if we come down here, you'll notice it says linear. So I'm in linear mode, so obviously I'm not going to see anything when my image is linear, right? You can see a star, really bright star kind of popping out. But if you actually want to see it, you can apply an auto stretch, like in high definition. Now you can see what one of my calibrated lights looks like, right? Because I have the sequence here. So this auto stretch, this is not really a stretch. It's kind of like a previous stretch, similar if you've used Fixed Insight or you've seen any videos of Fixed Insight, the STF, the screen transfer function, that's pretty much what this is. And so, yeah, you can see an image, right? You see it has a sequence selected and it says it's 34 images in that sequence. And it's showing me one specific image in that. And I see Wes, you've raised your hand.
Yeah, John, I just want to let you know it sounded like your audio is getting a little choppy there.
Feels better. Is the audio any better by chance?
It still sounds a little funky.
All right, let me try to see something. What about now?
That's better. There you go.
Cool. All right. So this is just an outer stretch of one image, right? If I want to look at some of my other images here, I would click in the sequence tab. I can click on open frame list, and then it shows you a list of all my frames, right? All 34 here. And it tells you, see when I click this one, this is my reference image. So when I go to stack them, it'll use this as the reference. And you can click another image here that you want as the reference. And so this is a good way now that I have them all calibrated, I'm going to go through them quickly, right? I can just use the arrows and see which ones I don't want to use, right? That are kind of bad quality. Had a satellite there, that's probably fine. But maybe towards the beginning of the night, right? Like these don't look like there were some clouds there. Definitely here. So maybe I want to exclude this one, for example, and that one, right? So just I'll click them here and close here. So these are already calibrated. So the next thing you would do is register them, right? And you will notice here on the image selection, since I selected a few, it tells me to register the selected images only, right? I can do all from the sequence, but I've already rejected some, so I want to see. Right. Before I registered the images though, because you notice when I went through here, for some of them, right, there were some clouds, some lights. I think I was imaging early in the evening on this one. There is a little bit of a gradient that I'll definitely take care of that once I have them all stacked. But to help it out, especially if you got an aggressive gradient, what you can do is go into image processing, background extraction, and then for interpolation method, do polynomial and do a degree 1, right? Which is linear, right? A polynomial of 1 is just a straight line, a linear. And what I'll do, I'm going to apply this to the sequence, to all the images here. And what this will do is this kind of a weak background extraction. Which is fine on a single image. So when I stack my images, the kind of background noise isn't as bad. Not the noise, but right, you'll have this weird gradient. The gradient won't be as bad, and then I can apply a more a better algorithm for it, but it won't be as strong, so it'll be easier to deal with the resulting gradient. So I close up accident. So again, background extraction. Now I need to apply some points. So I'll make sure when I apply them around to capture the background. I want to avoid my nebula, and I want to make sure I'm zooming in because I want to make sure I don't click on any stars. So I'll just kind of go around it, try to hit the corners, make sure my points would well define my background at the end. Here and here. It looks good enough. And then if I just now do compute background, it would do the background extraction just as image, but I want to apply the whole sequence. So I'm going to do apply the whole sequence. And I do apply. And notice that it has this output prefix BKG. So now I have a new sequence, BKG for background, where I apply that extraction to all the images in that sequence. All right, so that's the one I want to work with. And then by default, when Siril stacks them, it doesn't do any plate solving. And so if I want the solution to be in my image at the end, it helps with the stacking if you actually plate solve. So it knows what stars to pick. So to plate solve, I would use tools, astrometry, image plate solving, right? Because I'm using astronomy camera with a header, it automatically has the right ascension and declination added to it. If I were using a DSLR, for example, you would have to then type these yourself if you knew exactly where they were, or you can here type in, for example, California. Fine. Right, and it'll find your target, right? And you can click it. It is very finicky. When I've used a mirrorless camera, right? If you're kind of slightly off from what it's recognizing the coordinates for the target, even though you know for a fact that's your target, it won't solve. For what I've done in the past when I was using a mirrorless and it wasn't solving, is I've gone to this website called Nova Astrometry, and you can upload your image there. And I'll put a link in these slides. We can upload them, and plate solve it for you, and it'll give you the right ascension declination. And then I type those in here, and then it works. But since I'm using the header, you can get it from there. Right, this is the right focal length, right pixel size, everything's good. I click. Oh, now I want to again solve whole sequence. Click OK, and This uses an online database, so if you don't have an internet connection or it's slow, it can take some time, but this was pretty fast. It was cool. Just 34 images, so did that fairly quick. Close that. All right, so now I'm taking the background out of it and plates off, so now I can register. All right, so this is all good here. This works pretty much with the global star alignment, the registration channel. I mean, I only have luminous because this is a black and white picture. If you're using a one-shot color camera, it will let you pick any of the channels, red, green, or blue. So for a one-shot color camera, you typically want to pick the green channel because that's your strongest channel. And then now for on distortion, because we just plate solve, we can actually click here from image, and it'll apply that better. All right, so remember how we excluded some images, right? When we had this original sequence, it was, no, the flats. All right, so when I had this sequence, nope, that sequence, right, it was 34 images and we excluded 2. Then when I created my background sequence, right, it only did it on the images that I had selected, so the 32. So now with registration, that's why I want to say, okay, register all from sequence because I already took 2 out, right? It's already taking that into account. And all right, so now for here, I want to dressel them because I did dither. I typically like to do a scaling of 2, so a 2 times dressel, which means I gotta lower my pixel fraction, so it's all relative, right? So if I do 2, it has to be 0.5. If it's 1, this can be 1, so on. And I would now click register. And if you have a lot of images, this can take some time. You'll notice it's not as fast as the other ones. 34, so this will go pretty quickly. But if you're registering several hundred images, it can be 20-30 minutes. All right. And it also depends on your computer speed, right? My desktop here, it's pretty beefy, so it goes pretty quick. All right, so now that it registered, you can actually now go to the plot section and it'll show you some statistics here, right? So now I have my full width half maximum, which is basically, right, your stars are supposed to be pinpoint, point, if you've heard PSF, like a point source function, right, just a point. So the full width half maximum basically tells you how much that light is spreading from that ideal point source. So you'll notice all mine here are within 3.1, 3.79, that's fine. But maybe I had an image that would jump all the way to 10, which means that for that one, it's really out of focus. So I would want to exclude that one. Maybe here, roundness tells you how round the stars are, right? So 1 being round, 0 being basically an ellipse. All of mine are fairly round. The background, right, tells you the background value. So maybe it was a little bright at the beginning. There were some clouds, and the clouds went away, and it got pretty dark. So that's why my background value dropped here. All right. Again, if you have like a couple that are really big outliers, you can exclude them. I'm trying to get to some of them I can exclude to show. And then stars, right? Showing the number of stars in your images. So, okay, so now let's see down here, these 1, 2, 3, 4, 5, they don't have as many stars, right? 500 or some stars is 2,000. So maybe I want to exclude these. So I can just click and hold and draw a box. And then I right click and I do exclude selected points, right? In the circle X here, that's showing you the current image over here. So if I want to see this one, I can right click and do show, for example, and then it will show me that image. So maybe I also want to exclude, if you want to exclude one single image, you can just right click, do exclude. All right. So now once I'm happy with my selection, I would come to stacking. Okay, now for this, I want to do additive with scaling. once right signal clipping is fine. Now the weighting, right? Some images is gonna weight more heavily than others. You get to pick what you want, number of stars, full width at maximum, the noise, number of images. So I typically do full width at maximum. That works pretty well. All right, I don't want to stack all of them, right? We rejected some, so we want to stack the selected. I do the output. For my final one, I can force it to be 32-bit, and I'm 16-bit here. And what I want to call this, when I want to save it, I think, right, I have a folder here for calibrated lights. So I want to go back. So go back one folder, calibrated lights. And call this my lights hydrogen light night one. All right, and then I would click stacking, and it would go ahead and stack them. Right. So now I have a stack of the first night, which is great, but actually this is not what I want, right? What I want to do is I want to stack all 3 nights of hydrogen. So instead of just registering one night, I need to register all 3 nights, right? So what you would do is after you calibrate, you would come here and you will load those calibrated lights, right? So if I come to my working here, right, that would be these background ones, right? Because those are the ones I calibrated for night one. Then I would want to do that for night two. So that would be under working, which I don't have them, but right, I would create them. Then I would put them in here. And then for night three, the same thing, right? I would come to my working. I don't have these, I already deleted them, right? But I would add all 3 nights here, and that's what I would register, and that's what I would stack instead of just one night, right? So when I would do that, what I have left, let me change my working folder to multi-night. Right, so that's what you see here. I moved all over here, right? I would end up with something, which is the one. This is master. Right, this is my final stack night of 3 nights, right? And then I did the same thing for the hydrogen and the oxygen, and you'll notice. Sorry, let me change the working so it doesn't happen again. You'll notice I have them here as well, right? So that was master hydrogen. I got a master sulfur and a master oxygen here, right? So I have all 3 of my images. Right, so now let me open master oxygen. You can see what it looks like, right? The oxygen was very weak, even with the auto stretch, you can barely see it. It's in there. And then the sulfur, master sulfur, it's there, right? Unfortunately, there's no good way to like see all 3 side by side in Siril. You got to keep opening an image every time you want to see another one and close it. So that's kind of the annoying part of it. But right now I have my stacked images, all 3 of them. So now I can start, right? So now that's the stacking portion, which is great. Now I can start kind of massaging them and combining them into one image. right? Because I have 3 black and white images, but I want a pretty color image. All right. Let me we'll do the hydrogen since that one has a stronger signal. All right. So there are a couple things I can do, right? This is really this is still a linear image, right? There's no stretch to it. I haven't done anything to it, right? If I go back to linear, you'll see it here. Um, these are all different types of kind of like auto stretches, if you will. Auto stretch is just um, the easiest one to see your images, right? If I do a square root, kind of see what it's doing. It's just doing this to the histogram, like different things to the histogram, right? Hyperbolic, inverse hyperbolic sine, nothing there. Histogram is the really like overly stretched version of it. The cool thing about histogram is if you zoom to the edges, it kind of lets you see the stacking artifacts more. And so since Siril doesn't auto crop, histogram is nice because then you can kind of see where the edges are that have the stacking artifacts for you to crop it. But I'm not gonna crop these quite yet because I need to combine them first. So let's keep it on auto stretch. All right. So before I combine them and do any sort of stretching, I think it'll be easier to remove background if I need to from the images where they're still in black and white, and then do a little sharpening and a little noise reduction. We're combining them. All right. So for sharpening or for background, you have 2 options. You can do background extraction like I showed before. Now I would want to do an RBF. Click on my points and do compute background. Now I would hit compute background. This is just one. And honestly, this one, I don't know. Doesn't seem to me like there's much of background. But so I'm not gonna do it. But if you don't want to select the points manually, right? Since we did do Graxpert, we installed it. We'll go under scripts, Python, processing, Graxpert AI. It'll open the Graxpert window here, right? So we got a couple different operations. We can do background extraction, denoising, deconvolution, which is sharpening, right? On either the stars or nebula. So let's start with background extraction, right? Use GPU available, and then I'll get applied. This goes pretty quickly. And I get an image without a background. It did something. I don't know if it hurt the image or not, but I'm gonna keep it. And now I would want to do the deconvolution, right, which is the sharpening. And you always want to do the deconvolution before the denoising. And you want to do the deconvolution when the image is linear, because the denoising really changes changes the pixel values, right? And then when you do the deconvolution, deconvolution really or sharpening, or the convolution, it's a mathematical operation, right? Where is you have one signal, right? That it's tied up with another signal, like 2 signals multiply, right? And you're doing some process to basically separate those 2 signals. So that's what the convolution is doing, right? It's trying to figure out your original signal. And then there is something in your signal, some other signal that's making it be not as sharp as it can be. So it wants to basically take those 2 signals apart. This is just a really simplified way of explaining it. But if you stretch it or you're playing a denoising, you're changing what that original signal will be. So it's going to have a harder time doing the deconvolution. All right, so for deconvolution, you can set your strength, basically how big or small you want your stars. and it's asking you for the PSF size, right? The point source function, basically how big your stars are on average. Since we don't know that, unfortunately it doesn't compute automatically. We need to compute it first. So the way to do that is you come to image processing, star processing, and this gear icon. All right, now this is the dynamic PSF. It will ask you to select your star. So you click this button here with 3 stars in a circle. It'll select all your stars and it will tell you here what your full width half maximum is. That this is the value you want, so 3.34. And before I click here, I want to select this guy here to remove all the stars. So now I can go back to Rexpert, deconvolution stellar, right? I've set this to like 6. And where did it go? And for PSF, I would put that in there. Then I would click apply. I'm not gonna hit it now because it takes a little bit of time, even with the GPU acceleration. So once I do that, I would then hit the object. For object, I like doing the strength all the way at 1. I would say for stellar, you can play around with the strength and see how the stars look to you. It's kind of personal preference, how big you want your stars and how pinpoint you want them. For object, I like hitting it all the way at 1. Same thing, hit apply. And then after that, I would hit my denoising. And this takes even longer, so I'm definitely going to do it, right? You set up the strength. I would say for denoising, you can definitely hit denoising whenever you want. I like to do it at different stages, so I typically try to keep the strength pretty low because I'm going to keep doing the denoising. I find that that kind of helps better. I mean, in all of these operations, when you post processing, a little bit of a time, kind of at a time works best. So definitely try to do a little bit of denoising as you go, and you don't have to ramp all the way the strength all the way back. All right. So when that's all done, right, I have it. Should be saved somewhere here. I call it a Grexpert, right? After doing the Grexpert operation. So this is what it would look like. So this was my original one. No, sorry. This was my original one. And after the denoising, deconvolution, all that, looks like this. All right. So I'm going to do that to all 3 of my images, to my sulfur and my oxygen, or little hydrogen. And now I can combine them. All right. And there is a little bit, you'll see different tutorials online doing things differently. Some people like to remove the stars and do stretching on each image individually before they combine them. Some people just combine them as is, and then they remove the stars and do the stretching. I would say play around with it, see what works best for you, what works best for your image. I think it really depends on the target, right? The stretching it individually. In this case, I mean, you saw from the pictures that the oxygen is barely there. Definitely need way more time on that one. The hydrogen and the sulfur are pretty strong, and they're basically one big cloud. There's some faint stuff there, but overall, there's nothing really that I want to really protect as I'm stretching. Right? If for example I was shooting a target where the oxygen had something that was really faint, I may want to pre-stretch that one so I have better control over that faint portion of it. But for this one, I did it both ways when I was preparing for this. I didn't know the difference, so I'm just gonna keep it as is before I'm working. And you have your options on how you want to merge them. You can use pixel math, and I'll go over that here in a little bit. Right, if you want to do, so if I did pixel math, right, you can do an expression for your red, green, and blue. If you want to do a mixture of each image on these, if you just want to do straight SHO, right, your red, green, blue, you can do composition, RGB, compositing, yes. And I would select my images here, right? So I would come here and I want to, that's my expert one. Where did it go? Expert. Oh, sorry. For red, I want the sulfur. So this. For green, I want my hydrogen. There it is. And then for blue, I want the oxygen. All right. And I want to hit linear match. All right, so it matches the intensity of them. Now I get this green looking thing. And I want to do a line since I stacked each night separately, right? They're not necessarily all aligned. So I want to align them perfectly. All right. And now that that's done, I can close it. All right. So now I have my combined images, right? And this is still, they're still linear. I haven't stretched them yet. But this is what it looks combined. It's just one big green mess. And it makes sense that it's mostly green, right? Because if we look at the green channel, it's very strong, right? That oxygen, that hydrogen that we put in green, that this particular target is mostly oxygen. So it looks very green, right? There's like barely anything in the oxygen. And there is some right here, but it's being overtaken by this massive blob of green. So makes sense that our target here is mostly green. All right. So next thing we want to do before we actually start stretching is remove the stars. So to do that, because we install StarNet at the beginning, we come image processing, star processing, StarNet removal. It's going to pre-stretch the image, right? If you're doing this when it's linear, you want to hit this. If it's not linear, you already stretch it. You won't click it, but since I haven't stretched it, I would do this, right? It'll basically unstretch it back for you at the end. And I would click execute. I'm not gonna click it because it takes some time, but what it's gonna do is gonna create two files. And I have that one. I have those, right? It's gonna create a starless and a star mask. On that one. Oh, actually, I would say in this case, I don't want to do that. Yeah. So you notice how maybe some of these stars came out a little purple. So then my background, right? So what I could do is maybe unpurple those first. So I'm actually gonna do the SCNR, which is the remove green noise, to do that. So just one something I wanted to say about the remove green noise, right? I definitely, even though this is all green, you might be tempted to do that, or if you have another part of your nebula that's mostly green, to get rid of the green, but then you would be killing your green channel, right? And if we come back real quick to the PowerPoint, on how the SCNR works, right? What it's doing really, it's for each pixel, it's depending on what you pick, right? Because you can pick, you can pick average, maximum, minimum, additive. So what it's doing is, let's say if you pick the average or the maximum, for each pixel is going to either do the average of the red and blue or the maximum of the red and blue. And it's going to compare that against the green value. It's going to take the minimum of those, and then replace your green by the minimum of those two, right? So if I were to do it here as it is, it's basically going to destroy my green channel, all my hydrogen. But if I do the negative transform of this, you'll notice that all the purple became green and all the green became purple. And so now for some of these stars that were purple before, and to kind of get rid of that purple haze in my background, now I can do the remove green noise. And I go back to negative, I do another negative transformation, and now I have not purple in my background, and so my stars aren't purple anymore. So I would want to do that before doing the star removal. So now I can do the star removal and come back here, which is this. Okay. All right, this is what it looks like. And actually, when I was processing it yesterday, I think I mixed the masters that had not the Graxpert stuff to it. So the final one I got here won't look as nice as one before. So you'll notice it didn't remove all of them. It missed 3 or 4 or so. If I was being real anal, I could take this to Photoshop or GIMP or some other tool to remove them with a close step or a healing brush. Fortunately, Siril doesn't have that. But for these purposes, I think these 4 are not really going to bother us all that much, so we can leave it as is. All right, okay. So now I think we're ready to start stretching it, right? So what we want to do is get rid of the auto stretch, go back to linear. And I'm going to start, here comes stretches. I'm going to start with my generalized hyperbolic stretch transformation. All right. And so something to keep in mind here is I don't want my final image to be all green. So as I'm stretching it here, I'm gonna first start stretching all 3 channels at once, but then start working the green separate from the red and blue to try to reduce that green a little bit and try to get some other colors in, right? So for this first stretch, what I'll do is I'll go back to auto stretch real quick to select piece of the background. So I just click and drag, and then I make that my symmetry point. We go back to linear, and I'll drive this local stretch intensity all the way up. Then I'll start moving my stretch factor. And what I want to do with this first stretch is sort of keep going, right? You can start, the image starts appearing. I don't want to be super bright. I want to try to get most of the detail out. So I'm going to start stretching until I notice that I don't see any detail appearing, and all of I'm doing is just brightening the picture. So once I notice that all that's happening is that it's just getting brighter instead of getting more detail, I'll stop. So, and it does take some time as you move it. Sometimes you gotta wait a little bit. Sheet. I think yeah. So I have a cheat sheet here yesterday of what my value should be, right? So I think I got to around here yesterday. Yep. And I'll click apply. All right. And now I will do this again. Maybe now I won't do my stretch intensity as high, maybe around here. I will, and you notice on the second one now, I can't move my stretch factor as high as I had it up. Oh, so I'll blow it out, right? So it'll be very little small stretches. And I have these values already from when I was playing around with it, so I'm kind of tuning, but you would kind of go back and forward, see what looks good to you. So this looks good to me for a second one. I don't want it too bright yet. I'll click apply. And now, since it's fairly bright from before, I don't want to keep stretching all three channels because what I'm just gonna do is get a nice Grinch looking thing. So I'm gonna unselect the green channel by clicking here. Notice the green kind of disappears from there. Then I'll just stretch the red and blue. Right, I'll click my symmetry point again. It's already selected, so I'm just gonna click the eyedropper. And I'll just stretch those two separate. A little bit more here. And maybe I'll just reduce this intensity slightly. Because you'll notice I'll start getting another purple hue in my background. Just a little bit higher. But by doing that, you can already see there's some gold orange appearing there. I mean, that slight hint of blue in there. So I can already start reducing that blue. So I hit apply. So my black points here on the left. So maybe what I'll do now is I'll try to move them all to the left to try to get my background to be black again. So I will go to linear stretch, black point, and maybe I'll move all three at once. Oh, I didn't have the green selected, so I'll select the green as well. And maybe go fold these. And it'll tell you if you start clipping your data. So keep an eye on this. A little bit darker. Then I will come back here and maybe stretch all three channels again. All right, you can now start really seeing more of a color variation in the nebula. Just reduce this a little bit. And it's just kind of playing around with these dials, see what makes sense to you, right? Like then click my symmetry point, I'll do that. I would move these around. Now I'm really starting to see some colors there. See what's starting to look good to me. Maybe I would do this one more time before I really notice I start losing it. And the same thing, maybe just the next one, I'll just take the green channel out and just stretch the other two. For the sake of time, I'll just open the so this is what it looked like after that first stretch, right after I play with it a little bit more. And you really start seeing that color variation in the nebula. And again, I have less than 8 hours on this narrowband, so this is definitely not enough data to really give me a good image, but good enough for these purposes. But now again, you see the purple stars come back. My purple background came back, so I'll do the same. Negative transform. I'll remove the green noise. See this very green star there. Second. Now it's gone. And what? Okay, and so now what I can do, that's right? It's do a second stretch to kind of play with the colors a little bit more. But I'll do that now with the curves transform instead of the general hyperbolic stretch. So I get image processing, stretches, curves transformation, because that will give me a little bit more control over the channel. So, if I move the middle, the midtones up here, if I start moving that, it's the highlights. And back here, it's kind of like my darks, black point. So maybe we'll do that. Ooh, I like that contrast. Maybe I want to try to get a little bit more blue, so I'll turn the red and the green off. And if you click this preview here, right, it toggles the preview in your image, right? So it's not actually applied until you hit apply. So it's not. Oh, that made my nebula there a little bit more blue. And I'll lower that so I don't get that blue hue in the background. All right. Maybe I want a little bit more red, more golden. It's too much, right? So now it just becomes personal preference. Try to balance your colors. Again, it's kind of a weak signal because it's only less than 8 hours, but you get the idea, right? You just start moving this curve a little bit and see what looks good to you. See, now if I remove a lot of that red, again, it starts becoming more green. So if I right click, right, if I did something and I don't like how that looks, if I right click on that point, it takes it away. I like that one. Maybe now I can boost all three together. Maybe that's too much. Yeah, looks good. And I'll stop here for the sake of time. Now that it's done, maybe I would do another round of denoising, right? Because as I'm stretching, I'm adding some noise. So I would do some denoising, you know, 0.6 or so, again, because we might do another round after the stars. So it's done there. And then maybe before doing the stars, I can do color saturation. I can do add a little bit of saturation to my image. Maybe that's too much. And then maybe I want to make the blue a little stronger, and I can do again. Just select that one specifically. And again, notice is doing cyan blue, blue magenta, right from the color wheel we saw. So it's kind of hitting those there. All right, like that. Then another thing I can do is if I come to filters, this constraint limited adaptive histogram equalization. Notice it made it a little bit brighter, but it kind of also brings out some highlights. So I don't want it to be this bright. I can move the clip limit down a little bit to rein that in a bit, but still keep that detail. Looks good. We'll do that. Yep. Like that. Hit apply. That looks kind of decent for a quick job. And so now I think I'm ready for the stars. So before I had the stars, right, I haven't saved this since I started doing this, so I want to save. We'll do a different version. Right. That's this. All right. So now to add the stars, I click image processing, star processing, and now I do star recomposition. It's gonna say this is why I saved it, because it's gonna tell me it's gonna close this image without saving it. Are you sure? Right? Or we already saved this, so we're good. So yes. Now I have this menu here. My background stretch, so that's my nebula that I was working with. So it's this load there. And then for my stars, I'll hit my star mask. This is the one for when I was playing out yesterday. All right. And now I can start stretching my stars. The stars are still linear, right? We haven't done anything to the stars. If you start stretching it here, you notice that they don't look quite right. Kind of running out of time here, but you can go back and just open the stars and do the stretching yourself. Or if you if you're doing mono, a good idea would be to just take like 30 minutes of RGB for short exposures, right? If this exposure was 3 minutes, maybe I would do 30 minutes of 30-second exposures of RGB just to get nicer stars, right? I don't need that much time if all I'm focusing is my focus is the stars, because the SHO stars tend to look a little um, funky purple, as you saw. But for now, just for this, I'll keep it like that, and you start stretching the stars until it kind of looks good to you. You know, I kind of like my pictures to be a little starry. So I'll just keep going a little bit more. And that looks good to me. And then I'll click close. All right. And now you can start adding your final stretches. So maybe you want to do a little bit more denoising, or you want to play with the colors. Or you can go back to I like the curves tool a lot because it gives you a lot of um, control over your image. And this is some weird Siril thing. You notice, like when I click on that, it made everything darker. If I were to, I didn't save it, but if I were to reopen the image, it would go back to its original brightness. So unfortunately, I didn't save it. I have to close it and do the star edition again. But yeah, so this is basically Siril in a nutshell. Maybe let's just do that again real quick. Start processing, recomposition. There we go. And I will save it this time. Tutorial. Yeah. So, if I wanted to mess with well, I'm not going to do that because you'll see it might get dark again. But, maybe I want to add a bit more saturation. Might give All right, see, it got dark again, but this time I saved it, so I'm good. But yeah, this is pretty much it. Now you're ready for final touches, right? If you want to bring it into Photoshop, I like the smart. I'm not gonna do it here. I'm gonna try to keep it all free software, but the smart sharpening in Photoshop is pretty great, and because it could really highlight. See how there's some faint nebulosity as you move away. It could highlight that. But again, what would really fix a lot of this would be just having significantly more time. For this target, I want at least 20 some hours, not the shy 8 that I have, and that would really make it pop out more. Is there any questions on so far everything I covered? If not, I want to show just real quick before we finish some examples of when I was working around the image yesterday. I did a couple different things, and the first time I did it, as I was preparing for this was the resulting image, and then a couple hours later, I said, let me make sure I can do it again and get the same thing, and this is what I came up with. Then I realized I had taken too much out of the green out, adding too much red. So this image is this exact same one, but what I did is I went back with the curves tool and added a little bit more green. But other than that, they're pretty much the same. Basically the same steps I just went over. And then these two, actually, just for fun, everyone always does the Hobbit palette. I personally like how the James Webb pictures look better than the Hobbit, but it's kind of apples to oranges comparison, right? Because James Webb is infrared, so you can't really compare it. So I asked ChatGPT how I could kind of fake that's James Webb palette with the SHO images. So and it gives me two different options here. Um, and this was done with pixel math. Um, so the way to do that would be, was zero. I would come to pixel math and I would load my images. So in this case, it was my masters, right? So say it was these three. And I'll call this HA, S2, 3, and let me try to open this. I'll move this real quick over here and do what those values are supposed to be. Right, so according to ChatGPT, what I would want to do for red is this expression, right? Since I already said what this at 103 should be there, right? I want to do this for the green, and I want to do this for the blue. Right, again, you have to declare these variables based on your images, and it's case sensitive, right? You could all do a parameter, right? If I say k equals 1 here, and I do this times k, and I can save these as presets. And when I use these a lot, I can maybe hit these. And so now I have these presets, so I don't have to type them in every time, but hit apply. And remember, it was linear before, so I go back to stretch. So, I would have to do the same trick again. But maybe I want to do this on my images that I didn't do any noise reduction, so I could simply just change the image and go back to my masters. So these three. And I will change these. Oh. What? Those aren't aligned, so I would have to go and align them, and but yeah, that's kind of the idea. So that's kind of what I did there, and then I stretch it again. So it gives me two options. It says, if you want to get that golden hue from James Webb, it's the first one I put in. If you want to try to mimic what their near cam tricolor one does, it gives me some different equations. So I play around with it. But my point is, just with this, the stretching is really where you'll get all the different colors. So less is more, and just have fun with those curves. And I think that will do it, unless anyone has any questions. All right. Thanks,
All right.
everybody.
Anybody have any questions for John? It's interesting to see how similar and yet different. Like it's all so many of the same processes as like PixInsight or some of the other things. And you just do them differently. Like the stacking
Right.
process is a lot more manual. The generalized hyperbolic stretch is the same basically as PixInsights. It's just implemented a little differently. So it's cool to
Yeah.
see
Yeah.
even in a free tool you have all of these options.
Yeah. And they've been really adding a lot to it, I would say, in the last couple of months to try. I think everyone looks at kind of like PixInsight as the um,
It's like the gold standard. Yeah, yeah.
yeah, the goal, and they try to make it more and add more of those tools to it, which has been great.
That's awesome. That's
Yeah.
what drives everything forward, right? Is the competition. If they keep adding those
Yeah.
sorts of like cool tools to Siril, then maybe PixInsight will have to innovate and keep
Yeah.
producing awesome stuff. So
Yeah. So
awesome.
if you're just starting and you spend a bunch of money on gear, and now you need a software,
Right.
there's a lot of good free options to start. And I've gotten some really good images out of Zero.
Absolutely. That image looked great. So that definitely is a very capable application. I've never seen it used before, so that was pretty cool. So yeah. So if anybody doesn't have any questions, That was an awesome presentation from John on a deep dive on Cyril. And hopefully this is the first of a series of astrophotography videos that we're gonna
Yeah,
meetings we're
we
gonna
have
do.
another
So
one in December 4th, coincidentally. Again, we'll go over astrophotography and dive into the gear, how to connect it all, how to control it all. So I think that'll be a pretty good class.
awesome. Awesome. Thank you very much, John. And if anybody was here that wants to follow along again, I will be taking the video of this meeting and getting it up on our YouTube, and I'll post it on our groups.io in the next day or two so that if you have your own data and you want to follow along with what John was doing without having to go through your notes you might have taken tonight, you can just follow along on the video and see what you can do. All right.
All right. Thanks,
So
everyone.
thank you, everyone. See you next time.